Recall the so-called fundamental triangle between the points x1, y1 and x2, y2. These 2 points. The triangle has sides parallel to the x-axis and the y-axis. The side parallel to the x-axis has length x2 minus x1. The side parallel to the y-axis has length y2 minus y1. The slope of the segment connecting the 2 points is therefore the rise over the run y2 minus y1 over x2 minus x1, indicated by a boxed expression or number. The same triangle gives us the distance between the 2 points. By the Pythagorean theorem, the square of this distance is the sum of the squares of these distances. Therefore, this distance is the square root of the square of this distance plus the square of this distance. Now let's use some of these, well, actually let's go ahead and first reason out the midpoint of the line segment between 2 points. Okay, the midpoint between 3,7 and 17,13, well, if the point's halfway between here and here, then it's going to be halfway in the x direction, which will be the x coordinate will be the average of the 3 and the 17, which is 10. And the y coordinate of the midpoint will be halfway between 7 and 13, which is the average of 7 and 13, or again 10. The x midpoint is obtained by adding 17 and 3 and dividing by 2. That's to average the 3 and the 17 to get the number halfway between. And similarly, we average the 7 and the 13, 7 plus 13 over 2, to get the 10 for the y coordinate. More generally, if we look at the fundamental triangle, we see that the midpoint is going to occur at a point that we could calculate by averaging the x coordinates, x1 plus x2 over 2, and averaging the y coordinates, y1 plus y2 over 2. We also note, if we zoom in a little bit, that the midpoint occurs at the end of this triangle here, which is similar to the large triangle, but half as large. Not half as large, but with half the dimensions. If large means area, of course, it's only 1/4 as large. Okay, so if we take a triangle with half the dimensions, the triangle halfway across here and halfway up, the run is going to be 1/2 of the x2 minus x1 run of the large triangle. The run of the small triangle is going to be half the run of the large triangle, half of y2 minus y1. To get the coordinates of this point, therefore, we would start at x1, y1, and add the displacement 1/2 x2 minus x1, and add the displacement 1/2 y2 minus y1. If we add x1 and 1/2 x2 minus x1 and simplify, we do get x1 plus x2 over 2. We do y1 plus 1/2 of y2 minus y1 and simplify, we get y1 plus y2 over 2. You should probably do that just as an exercise in algebra, and also to convince yourself that these expressions are identical.